We've looked at translating graphs, which is moving the graph around, but today we're going to be looking at stretching the graph, either on the x-axis or y-axis, or reflecting the graph in the x-axis or the y-axis. Here we have a sketch of y equals x plus 1. If we multiply the whole function, the x plus 1, by 2, you'll notice that each point on our graph is twice the distance from the x-axis. If we only multiply the x term by 2, we'll notice that each point on the graph is now half of the distance from the y-axis. If we negated the function by multiplying it all by -1, the graph reflects in the x-axis. If we negate only the x term, the graph reflects in the y-axis. Let's have a go at these questions. We're going to start by sketching the graph of f of x, and it's just a simple quadratic. For 3f of x, each point on the graph will be 3 times higher up, so it will look like this. Remember, you're looking at the distance between each point and the x-axis and just roughly timesing it by 3. Sketches don't have to be perfect, but just make sure that it looks obviously higher up for each point on the sketch. We're going to start by sketching out g of x. Now it's a cubic, it's a positive cubic, and the roots will be 1, -2 and -2. We can also find the y-intercept by substituting in 0, so it'd be -1 times 2 times 2, so it'd be -4. Now to find g of 2 of x, we know it's going to be to do with the horizontal side, the x side, because it's inside the function. But instead of timesing all of the x coordinates by 2, we actually do the opposite. So similar to when you translate, when it's plus it moves left, when it's minus it moves right. When you times it by 2, you actually divide each of the x coordinates by 2. You're halving them. So our sketch will look like this. Notice that we need to put in our intercepts. So the -2 root will turn into a -1. The 1 root will turn into a 0.5. But it's going to stay the same on the y-intercept because we're looking at the distance from the y-axis. And obviously on the y-axis will be 0. So it's just halving the distance from the y-axis when you've got a 2 inside the function, that times 2. There's a couple of things going on with this question. We've got a times 0.25 and the fact it's a negative. So we're going to deal with those two things separately, but we're going to start by drawing a h of x. It's going to be a quadratic and it clearly has roots at 0 and -3. So we need to make sure we label that on. We're going to deal with the minus first. When you have a minus inside the function, it's going to reflect it in the y-axis. So we're just going to reflect this into the y-axis, and that will give us h of -x. Next we have a quarter times by a quarter. Now remember, when it's inside the function, you do the opposite. So instead of times a quarter, we're going to times every point by 4, every x coordinate by 4. The biggest one will be that x-intercept. So the x-intercept at the moment is at 3, and we're going to times it by 4, so it's now going to be at 12. And you want to make sure you show the graph is obviously stretched outwards. The y-intercept, as always, will stay the same because we're looking at the distance from the y-intercept, the x-coordinate, and x is obviously 0 at the y-intercept. And let's finish with this. F of x and f of -x look identical when f of x is x squared. Find multiple ways to explain why this is the case. If you know, I'd love to hear from you in the comments below. And you can come to onmaths.com or click the link in the description where you can access all of our A-level papers and predictions for free, and you can even save your scores with a free account. This video is part of a larger A-level course that you can follow along with at onmaths.com.